Am I audible? Hello? Am I audible? Am I audible?
Yes, sir.
Okay, thank you. So today we will discuss some more free body diagrams. Okay, after that we will move to solution of the equilibrium questions. Okay, so this question I have selected, that is from your textbook. The question number is 5.7. Okay, so here it is written that draw a free body diagram for each member of the system, neglect the weight of the members, replace the distributed load by a resultant. Okay, so there are some members. Say this one is the first member. Okay, okay, and this one is the second member. This one is the third member. Okay, so these three members are there. 1, 2, 3. Okay, and this is been supported at A, D, C, and D supports. This is B, and this one is, say, this one is E, and say this one is F. Okay, so basically three members are there, one pulley is there here. So with the help of that pulley, one weight is applied. Okay, so here all supports are being supported and only one weight is given, that is say Wx. Okay, W is related to x actually, W Newton per meter for example, and the length is given here. Okay, that is A length from B, from the B support. Okay, so first I will do that. This one, this is say B, and this one is A. Okay, anywhere here, that is C, and from C or from B at a distance, this one is the uniformly distributed load. Okay, so you have to apply this, you have to convert this. This is the A distance, and this is from here to here, that is B. Okay, so you have to convert this, uniformly distributed load into a concentrated load. Okay, this is A. Okay, so at the center point it will be there, and you are going to remove this. Okay, you have to remove this. So this will be like this. So W into A will be the load. Okay, clear, which will act at the CG, that is A by 2, and this one is A by 2. Okay, clear. Now at C point, this DF member is there. Okay, DF member is there. So here you have to apply Bx. Say this one is By. So this one is Ay. This one is Ax. Similarly, we will get that Cy and Cx. Okay, so the first free body diagram where you are using this concentrated load Wa. Okay, now vertical member is there, that is this one. Okay, this one is F, this one is C, and this one is D. Okay, to C, opposite to that, this one Cx. Okay, opposite to this one Cy. Okay, F is there, so this one say Fy, Fx, and here you just take dx and dy. Okay. Now the third one link is this one, which is connected to A and D. This one is D, this one is A, and in between anywhere it is E. Dimension is not given. Okay, what is the length? Length is not given. So this is E I have taken. Okay, this is E. From E there is a rope, so this will be tension in the rope, and reverse of that one, this is dx, reverse of this dy, this is dy. Okay, here this is E, tension will be there, and A, this one, so reverse of that one, ax, this ax, reverse of that one, ax here, ay here, so ay will be reverse to that one. Okay, ay. Okay, now these are the free body diagrams of three linkages. Okay, and the pulley is there. Okay, this one, say G, say G pulley. So G pulley is there, this will be tension, and this will be W weight. Okay, this is a free body diagram of this one. This question 5.7. Okay, 5.7. Now the second question is 5.9. I have taken 5.9. Okay, here again there is a fixed support and one roller support is there. Okay, a triangular load is given. A triangular load is there. Okay, a triangular load is there of length 10 feet, and on the other side there is this height from 0 to increasing up to 2 lb per foot. Okay, so you have to convert this into a concentrated load. It is said in the question that draw a free body diagram of the beam, replace all distribution by simplest equivalent force system. Okay, neglect the weight of the beam. Okay, so you have to use a equivalent force system of this triangular load. Okay, so this one, so what is a triangular load? Will be 1 by 2 into 10 into 2. Okay, so it will be 10 lb, and where it will act? At the CG. Okay, so this is, say this one, so I'm removing this support. Okay, I'm removing this support, so you will get the support reaction. Here you will get the support reaction, say something. Okay, that is, say this one is A point, say this one is A point, and this one is B point. Okay, so if this is A point, you just take A, and this is B, so B, Y will be there. Okay, and here you will get AX, AY, and moment. Okay, and moment MA. Okay, so as per the concept, I am taking this AX, AY, and moment, and you support this load will be anywhere here. So this one will be 2 into 10 by 3, and this is 10 by 3, and this is how much? 10 lb. Okay, so as only vertical load is there, so your AX will not be there. Okay, directly you can write that, but this is the free body diagram. You have to apply each and everything. So when you are going to calculate that, so you will get AX equal to 0. So here this is AY, AX, this is A location. Okay, and this is MA, and this one is roller support, you will get dy, and this one is the 10 lb at a distance 10 by 3 feet. Okay, so this is the free body diagram of this one. Now the next one is, I have taken this, okay, where both sides are fixed support. There is a first member is this one, second member is this one, okay, and pin joint is there, and the load is given, say F here, and this one is W0, for example, and this one is, say, W1. Okay, clear? So this question number is 5.10. This is 5.9 and this is 5.10. Okay, so this is there, okay, and this one is there, okay. There is a pin. So as you can see that this is the uniformly distributed load throughout the length, okay. So this one is W0. From here, from the hinge point, this triangular load is also there, okay, and this total one is W1, okay. So this one will be how much? W1 minus W0, okay, clear? And this is a uniformly distributed load. So basically it is divided into two parts, okay. So if you are going to divide into two parts, so this is the first part, and one force is also there here, okay, one force is also there, clear? So in this case, this is the uniformly distributed load, okay, this is the uniformly distributed load, okay, and at the pin there is a force. So this one is A, this one is B, this one is C. So I am saying this B, so this will be like this, okay. So this one is Bx, Bx prime, By, and By prime, okay, and this is F, okay. And here you will get that, for example, here I am taking this Bx, okay, and By, and here you will have this Ax, Ay, and a moment at A, clear? Similarly, you will have this one. There is a uniformly distributed load along with triangular load, okay, clear? So it is like this, okay. So this will be, say, sorry, opposite to that, what we have taken, this is Bx prime, okay, By in the upper direction, so this will be By prime, okay. Now here, say this one is C, so is Cy, okay, Cx, and M at C, clear? So this will be the free body diagram when you are using the distributive force system. You have to place this is W1 minus W0, and this one is W0, and this one is W0, okay. So when you are going to convert this, so just consider the length. So this length is, say, something, say L1, and say this one is L2. It is not given in the book, so I am assuming that this is, say, L1 and this is, say, L2, okay. So if you are using this, so this will be, rest things are same. This is Ay, this will be, sorry, opposite direction I have taken, Ax, M at A, at the center you will get that W0 into L1, Okay. This is W1 is not given as per length, it is given the total load. Actually, this total load, for example, this is W न्यूटन पर मीटर अगर ले लेते हैं तो L1 से मल्टीप्लाई करना पड़ेगा, टोटल दिया है तो टोटल को एज इट इज डाल देंगे, ठीक है ना। तो हमने मान लिया कि लेंथ के ऊपर डिपेंड कर रहा है, न्यूटन पर मीटर में दिया है। जस्ट अज्यूम दैट टोटल लोड ना देके पर यूनिट डिस्ट्रीब्यूशन दिया है, पर यूनिट लेंथ के हिसाब से। दिस विल बी W0 into L1, okay, and this will act at a L1 by 2. This will be L1 by 2. Similarly, here we'll get that Bx, and this one is By, dy. Okay. Similarly, the second part you will have Bx prime, By prime. Okay, and here your Cy, Cx, just like you have drawn, and this is Mc, and the weight anywhere here will be W0 into L2. Okay, anywhere here that will be W1 minus W0 into L2 divided by 2. Okay, clear? This length is how much? L2 by 3, and this one is L2 by 3 2 times, and this one is L2 by 2. This one is L2 by 2. Okay, is it clear to all of you? Hello? Hello?
Yes, sir. Yes.
So these are some problems, 3 problems. Okay, now I'm taking one problem that is related to truss type structure. When at a point there are 3 members. Okay, so when this type of situation is there, in that case you have to use the, along the member you have to apply the reaction forces. For example, this is the member first. Okay, second member is anywhere here. Okay, third member is this one. Okay, and fourth member is this one. Okay, in the first member there is a uniformly distributed load like this, and this one is say 7 kilonewton per meter. Okay, load is here given, that is 15 kilonewton. This question number is 5.31. Okay, one more load is here given, that is 10 kilonewton. Okay, this segment from here to here, this length is given, this angle is 20 degree. Okay, from here to here, this one is 0.4 meter. Okay, this to this, that is given 0.2 meter, and from here to here, this one is given 1 meter. Okay, now this one is A notation, this is B, this is C, this is D, and this is the upper one. Okay, so in the question it is said that what are the support forces at A and D. Okay, this is the question. I'm not trying to solve that question first. I'm Today I will draw the free body diagram only. From the next class, tomorrow's class, okay, I will solve some problems. Okay, so here this is uniformly distributed load. Okay, so as basically I want to tell you that in this drawing, if you are going to see the joint B, so B joint is in such a way that there are three members. Okay, this angle is 20 degree. Okay, this angle you can generate, you can find out with the help of this triangle. Okay, because this is 90 degree, this length you have to, you can calculate that what is the length as per the dimension, and then you can get the angle. This angle is given only. Okay, clear? The angle between the horizontal line and this length is given. So basically this is the joint where three members are passing. Joint. Okay, so if you are going to use this joint, this is B joint, and here one is vertical, one is inclined, two members are inclined. This is not at an same angle, at a different angle. Okay, at a different angle. This slope is less and this slope is more. This slope is say more, like this. For example, this difference दिखाई दे, this angle is 20 degree. So if this type of question is there, so you have to apply the, along the member you have to use the reaction forces. So for example, if you are going to join this one, so you have to use this triangle. Okay, so this one is FBC, FBA, and this FBE. Okay, if this type of drawing is there in the question, so you have to use along the member the forces. When you are using the along the member, so whatever is the angle of the member, according to that you will get the component in vertical and horizontal direction. Okay, clear? So for example, if you are using the BC member, so here it will be active load, that is 15 kilonewton. Okay, again you have to use the P here. If you are going to use the B point, so just like as I have used this one, so this is 10 kilonewton also active load, and here this angle is given at an angle 20 degree. Okay, this angle you have to say theta, you have to find out with the help of this triangle. Okay, this length is how much? Total is 1.2 minus 0.4, so that is 0.8. And this one is how much? This one is how much it is given? It is given 0.4. This one is also given 0.4. This one is 0.4. Okay, so you can get the value of this hypotenuse and you can get the value of theta. Say this is theta and this is say alpha. Okay, so I have taken this theta, this one is theta. Okay, clear? So this is the free body diagram of this point. Okay, now you have to use this along the member, so this will be on this is FCB. Okay, FC to B, and this one is this one. Okay, clear? And say two forces are there, that is Cx and Cy. Okay, if weight of the member is given, so you have to apply the weight of the member. Okay, and if it is not given, then there is no need to use that weight. In the question it is not given. Okay, similarly, so this one, this is C point, this is E point. Okay, this is E point. Okay, and this is D point. So dx dy Okay, this is hinge support, so no moment will be there. Opposite to this one is Cx, Cy. Okay, clear? Again, here again you have to draw the pin. Okay, so if you are removing this one, weight, so this will be Cx prime, this will be Cy prime. Okay, here it will be like this, 15 kilonewton Cx, Cy, Cx prime. ओके, इसको सी वाई नीचे बनाया, सी वाई प्राइम ऊपर आएगा सी वाई प्राइम. ठीक है, एंड हियर so this one is Fe, Ey and Ex. Okay, and whatever is the weight, that is 1 meter load, 1 meter length and 7 kilonewton per meter. So 7 kilonewton will be there, and it will act at a distance 0.5 from here. So that will be 7 kilonewton. Okay, similarly you will get the middle member, and similarly you can get the this one. Okay, so here your B you have taken, so this will be F B. Here you have taken this way, so opposite to that you have to take this one, F A B, and this one is D, this one is A, say this one AX AY, this one is opposite to, this one is E actually, EX EY. Okay, this one is EY. So this way you have to draw the free body diagram. So as per the question you have to think what type of solution how can you solve the problem. As per that you have to use the free body diagram. Basically free body diagram in all way you have to draw that. Okay, so these are some questions. Okay, तो इसके बाद नेक्स्ट क्लास में मैं आज इतना ही रखता हूँ, मुझे कहीं जाना है आज. सो फ्री बॉडी डायग्राम कुछ मैंने सॉल्व किए. ठीक है, और प्रॉब्लम इसमें बहुत ज़्यादा है, तो ये चैप्टर थोड़ा सा लेंदी रहेगा, काफ़ी 2 हफ्ते तक चलेगा ये कम से कम. ठीक है, तो इसके न्यूमेरिकल कल से सॉल्व करना शुरू करते हैं. ओके, तो आज इतना ही रखता हूँ. इसमें जो फर्स्ट एक्सरसाइज है, first exercise related to free body diagrams. Okay, the first chapter, first question is related to one lid, a box type structure where a lid is there. So each and every question is very important, very good question. Try to draw the free body diagram. For example, I am giving some questions, I am saying some question number. Okay, so try to solve those questions. Okay, draw the free body diagram. Okay, question number say 5.1. Okay, and 5.3, 5.8. Okay, 5.11. I will give the solution. Okay, I will give the solution of these questions. And 5.6 also. So 5.1, 5.3, 5.6, 5.8, 5.11. So these questions are there. You have to draw the free body diagram. Okay, draw FBD for these questions. Okay, and the book is ISAM's 4th edition. Okay, engineering mechanics ISAM's 4th edition, and question number. This is the first exercise of your equilibrium equations chapter, equations of equilibrium. Okay, equations of equilibrium. You have to draw the free body diagram for this question. Okay, these questions are some real practical, real engineering problem, real practical, just like the box type structure, a tractor trolley, a boat, okay, a plier, and a cutting plier also. Okay, so these some good examples. Try to feel that question, and I will give the solution. Solution will be given by me. अगर कोई प्रॉब्लम है तो मैं इसका सॉल्यूशन दूंगा. ठीक है, इसका सॉल्यूशन मैं बना करके ड्रॉ करके कल आपको दे दूंगा. ठीक है. One more thing, one assignment is there. Some 10 to 12 assignments are there. Okay, and for that assignment, for those assignments, actually you purchase a register and try to solve each and every problem from those assignments. Okay, in that register. Okay, और उसका फोटो बाद में एक सिंगल कॉपी में आपको आफ्टर द classes over, when the class 15th November, after 15th November you can submit that in a single PDF file. Are you getting my point? Hello.
Yes, sir.
तो
yes.
ये 5 क्वेश्चन है. 5 क्वेश्चन आप इसको ड्रॉ करने की कोशिश करिए. अगर नहीं होता है तो इसका सॉल्यूशन मैं दे दूंगा. तो आज मैं इतना ही रखता हूँ, मुझे एक जगह जाना है, तो नेक्स्ट क्लास में इसको सॉल्व करने के बाद इसका सॉल्यूशन तो मैं दे दूंगा, क्योंकि फ्री बॉडी डायग्राम है तो इसे सॉल्व करके फ़ोटो भेज दूंगा. तो और असाइनमेंट का कोशिश करूँगा कि अभी दे देता हूँ थोड़ी देर में. तो उसको जो चैप्टर हो चुके हैं, दैट मीन्स 4 चैप्टर तो हो चुके हैं. 4 चैप्टर से रिलेटेड जो वेक्टर एनालिसिस है, वेक्टर एनालिसिस के कुछ क्वेश्चंस हैं, कुछ रीडिंग असाइनमेंट है, कुछ न्यूमेरिकल्स हैं, वो आप एक रजिस्टर परचेज कर लीजिए, उसमें करते रहिए. ठीक है, और उसमें कोई डाउट है तो आप पूछिए.
So will rule register work, or we have to like do it in plain only?
इट्स योर चॉइस. अगर प्लेन लेते हैं तो ज़्यादा अच्छा रहता है, क्योंकि ड्राइंग बनाना होगा, फ्री बॉडी डायग्राम बनाना होगा, तो उसमें ईजियर रहेगा. ईजी वे में आप ड्रॉ कर सकते हो. तो आपकी किसी दूसरी लाइन से जो आप फोटो खींचोगे तो उससे कंफ्यूजन नहीं होगा. रूल्ड बुक होगा तो उसमें लाइंस जो बनी होंगी उसमें प्रॉब्लम हो सकता है कि कोई दूसरी लाइन कंफ्यूजन क्रिएट करे, बिकॉज यू आर टेकिंग द फोटोग्राफ, सो इट विल बी लिटिल बिट मेसी. ओके, तो हो सके तो आप A4 टाइप का पेपर लें. A4 वाला रजिस्टर एक आता है, उसे परचेज कर लीजिए. तो उसी में सारे क्वेश्चन करिए, तो आपके एग्जाम के लिए भी तैयार रहेगा आपका. ठीक है ना? ओके.
सर असाइनमेंट्स कब देंगे? क्लास के बाद?
हाँ, आफ्टर 15th नवंबर. 15th नवंबर तक क्लासेस हैं. लास्ट क्लास 15th नवंबर है. ठीक है, तो उसके बाद वो जैसे जैसे जो चैप्टर खत्म होता जाए उसका असाइनमेंट करते रहिए. ठीक है,
ये सेकंड असाइनमेंट है ना, ये जो 5 क्वेश्चंस दिए?
नहीं, ये असाइनमेंट नहीं है बेटा, ये तो मैं सिर्फ आपको करने के लिए दिया है. असाइनमेंट आपको एक फाइल पूरी भेज देंगे जिसमें सारे असाइनमेंट होंगे.
अच्छा ओके सर।
ठीक है ना, उसमें कुछ ऐसे भी हैं जो सिलेबस से हटा दिए गए हैं चैप्टर्स, वो सारे असाइनमेंट भी उसमें होंगे, लेकिन जो चैप्टर मैं डिस्कस करूंगा सिर्फ वही आपको करने होंगे। ठीक है, ठीक है ना।
यस सर।
हाँ तो आज यहीं तक रखता हूँ मैं। ओके, थैंक यू। जस्ट वेट फॉर अ मिनट, आई एम गोइंग टू टेक योर अटेंडेंस नाउ।